006. Debug and release use different engines. JIT versus AOT compilation. Your Flutter app in debug mode and your Flutter app in release mode are not running the same engine. They're not even close. Quick question. You have a list view builder with 10,000 heavy items, and it's dropping frames like crazy. Why? Is it A, the code is unoptimized, B, the emulator is slow, or C, you are testing an illusion? The answer is C. You're running in debug mode. The performance you see isn't real. I used to think debug mode was just the release app with a few extra logs attached. I was debugging a problem that didn't exist. Same kitchen. Completely different mode of operation. The Dart source code is the same, but how the chef executes it is about to change. JIT is cooked to order. The chef reads the recipe on the spot. The pro? It's flexible. You can change the seasoning mid-cook. And that's exactly how hot reload works. The con? It's slower, because the chef has to read the recipe book every single time. AOT is meal prep. Everything is cooked, portioned, and sealed the night before. The pro? It's incredibly fast. Just grab a box and reheat. The con? If a customer wants less salt? Too late. The box is sealed. And hot reload? Not possible. Here's what the JIT engine actually looks like. Dart source code goes into the Dart VM, which compiles and executes at runtime. The VM compiles your code to machine instructions while the app is running. That VM overhead is what causes the lag you see in debug mode. But that same flexibility is what enables hot reload. The VM can accept new source code on the fly. Now here's the AOT engine. Dart source code goes through the AOT compiler at build time and comes out as a native ARM or x86 binary. Your entire app becomes native machine code before it ever reaches the device. No VM compilation overhead at runtime. Pure, raw performance. Let's lock in the comparison. Compile time. JIT compiles at runtime, cook to order. AOT compiles at build time, meal prep. Speed. JIT is slower due to VM overhead. AOT is native fast. Hot reload. JIT supports it. AOT does not. Output. JIT produces Dart bytecode plus VM. AOT produces a native ARM or x86 binary. Best for. JIT is for development. AOT is for shipping to users. Now here's where it gets dangerous. This code imports Dart convert, decodes a JSON response, and casts data names as list string. In debug mode, it passes. No errors. The JIT compiler lets sloppy dynamic typing slide to keep you moving quickly. But in AOT mode, the same code crashes. The AOT compiler strictly enforces types and throws a type error. Typeless dynamic is not a subtype of typeless string. AOT also removes unused code via tree shaking and can change race condition timings due to its sheer speed. If you only test in debug mode, you're playing with fire. Now here's a reality check. You might assume AOT is always faster than JIT. Not entirely true. In long-running server applications, like server-side Dart, a JIT compiler can actually outperform AOT. Why? Because JIT can monitor real-time traffic and profile the app, optimizing the recipe on the fly based on actual user behavior. AOT cannot learn at runtime. But important, this applies to server-side Dart, not Flutter mobile apps. Flutter release builds always use AOT for predictable performance and smaller app size. Same kitchen, different mode. Debug cooks to order. Release serves meal prep. Never confuse the two. Next episode. Now you know why hot reload works in debug but not in release. But what exactly happens to your state when you hot reload versus hot restart? Episode 007. Change the recipe or throw out the dish. See you there.